Hello and welcome to my YouTube channel. This is Ramani Online Mathematics. Please, if you know you have not subscribed, try to subscribe and share to your colleagues. We are still on the method of a solution to differential or partial differential equation, and we looked at the directional derivative. That's one method. We are now looking at another method called method of characteristics. So for the method of characteristics, we have this formula that we are going to use. You are familiar with the A and the B. Is the F that is Newton. After getting your A and B, the rest of them becomes your F. Let me put it that way. Okay. Now for this one, to us, we are going to solve them according to the linear, the semi-linear, the quasi-linear, because some of them are very difficult. So I have decided to group them in terms of the solving. But in the exam, it's not be stated is linear or non-linear or semi-linear, whatever. No. I have decided to group them like that, okay? To solve them. So when I take linear questions, you solve. You also take semi-linear question, you will solve. Quasi-linear question, you will solve. That's what you are going to do. Okay, so let's look at the first one. So this is a linear. This is linear. If you look at this one, first thing, and you also know that you have solved this question before when we are using the directional derivative. So here, let's identify our A, 4, B, -3. Our F will be 0 because it's that 0. If you take this and that, the rest is 0. There's nothing there. So we are going to have the X over A equals dy over B equals du over F. So because this one is the A is for the X, that's why we are taking the X over that, dy over B. This not delta, is D, not partial, and the U over what? F. Now in this case, this place will go to 0. So here you won't do anything with it, it will go to 0. So we are going to tackle with this one. So here we have the X over, now our A is 4, our B is -3. So the F over A equals dy over -3. Is that okay? So if I do cross multiplication, I'm going to have -3 dx equals 4 dy. So here we can integrate them. If I integrate this, that gives me -3x plus c, because if I integrate this, I'll get 4y. You see here, I'm bringing c because this is not partial. We are using the normal differentiation, so constant will still be c. Okay. So if I make c the subjects, I'm going to have 4y plus 3x. Now, you also know that you need to get the function u. So this is the definition. The function u is always equals the function of the constant, okay? So that's the definition. Take note of this definition. Anytime you solve this and get your c, the function u is u here is equals the function of the constant. So u will be equals to f at 4y plus 1, 3x. Now after getting this, the condition is given. So wherever we see x is 0, y is y. So here we are going to have f at, they say y is y, by x is what? 0. It means I have 4y. This will go to 0. is equals to y cube. So you let p to be equals to 4y. You make y the side, you have p over what? 4. Already done this thing before, so means that if I come here, my f at p is now going to be, wherever you see y, you put p over 4 there, so p over 4 cube. So f at p is equals to p cube over 64. Is that okay? So that's what you are going to get. After that, you come back to the function here. It means that wherever you see p, you're now going to put fy plus 3x there. So let's see. So 4y plus 3x will be equals to, so this is going to be 4y plus 3x cube over what? 64. So therefore, our u will be equals to 4y plus 3x cube over 64. Already I have explained this because we know that u is equal to this, and this f of this is also equal to this. Means that u will be equals to that. Where is it? This one. So it's the same thing like what you solved. So if you go back to the previous ones, you realize that we had the same answer when you use the directional derivative. The previous video, you see that. Is that okay? Now let's look at another example. Okay, example 2. Find the general solution of the PDE. Use our script s plus uy plus u equals 0. So now, we are using the method of characteristics. So you know the method of characteristics, our a in this case will be 1, b will be 1. Is that okay? Now, what will be our f? Our f will be negative u. Let me tell you this. When they give it to you, these ones should be here. Whatever that is left should go to the other side. So this u have to go to this place. That becomes negative u. Is that okay? So here, if you code our formula, dx over a equals to dy over a b is equals to du over f. Dx over a will be dx equals to dy, because over 1 is still the same thing. Then du over negative u. Now, we have two equal sign here. You cannot solve all of them together at the same time. So you pick 2 and solve. Then next one you go and pick. So if I pick this and solve, then the next one I'll pick this one and that, or this one and that to solve. It's the same thing. So let me pick dx and dy first to solve. So dx is equals to dy. Then you integrate. If you integrate dx, you have what? X plus the constant is equals to, if you integrate this, you get what? Y. So in this case, you can say that our constant will be equals to y minus x. You can name this one as c1. Okay, I know why. I'll explain to you the reason why. Now let's move to this. Here you can decide to pick this dx and the du, or dy and the du. So let me pick dy and du. Anyone you pick, get the same thing. So here is dy will be equals to du over what? Negative u. So this negative, let me multiply the negative here, so that I have negative dy equals du over u. Now you integrate. If you integrate this one, this gives you negative y equals to ln u plus ln c. Is that okay? Let me name this one c2. So the reason why I was naming the c was that you are going to get two constants. That's why. Now if you look at this one, I'm bringing the ln to the constants. You know why? There's ln here, so I can decide to do so. Okay. So in this case, I have negative y equals ln c2u. So you take e on both sides, you have c2u equals e to the power negative y. Is that okay? So you have to make this c2 the subject, so that I have e to the power negative y over u. Now after getting this, this is what is going to happen. You see, this is C1, this is C2. So one should be the function of the other. But the one that is going to be inside the function of f should be the one that is not carrying u. If both of them are carrying u, then you can put any. But if one is carrying u like this, this is having u, this is not having u, then you put this one in what? The f. So this one is going to be C2 equals f at C1. So you see the difference between this and the first one. The first one was just one constant. So that one, it should be u equals the function of what? C. But when we have two constants, then one constant should be the function of the other. So here, my C2 is over u equals f of C1. But C1 was y minus x. Okay. We need to make u the subject. So you know that I can write u as 1 over e to the power y f at y minus x. You can write it like this. Yes. You see, this place, someone can decide not to bring the length and solve it like that. You also get the answers here is a general solution, might not be the same. But when it comes to the particular solution, like if it was initial condition was given to us and we have to substitute, no matter what the general solution you had, you all get the same answer. So it doesn't matter. If you are confused about this one, cross multiplication, the u will come here, the f at y minus x will be here. And this is negative. When it comes, it becomes positive. So this is that. So therefore, the general solution of xy will be 1 over e to the power y f at y minus x. So this becomes the answer to this question. Let's look at the last one and we move on. Okay, now let's look at the last one. Under this, you can pause the video and try. Okay, solve the equation y(x) plus xuy equals u. You are still using the method of characteristics. I'm saying that in the exams you'll be asked to use a particular method. If the question did not ask you to use any method, then use any one of them that you think is okay to you. So here, our A is y, our B is x, then our F is u. So I have the x over y, because A is y, equals the y over x, equals the F, the u over what? U. Okay. So the first thing, we compare the first two. If I compare the first two, I'm going to have the x over y equals the y over x. See, this one, I cannot integrate this because this is y. So this y have to come here, the x come here. That one can easily be integrated. So x dx equals to y dy. So here we integrate it because it's not been separated. Now, if you integrate this x with respect to x, we have x squared over 2 is plus c over 2, c1 over 2. Okay, let me bring it here. If I integrate this, I'm getting x squared is equals to y squared. Here is over 2, here is over 2. I'm bringing the constant is c1 over 2. I'm saying that the constant can be anything, so it goes with whatever that is moving with this and that. So here is over 2 over 2. So I can bring over 2 with the constant so that all the 2 will go away. So I have my c1 to equals to y squared minus x squared. If you make c1 a subject, this is what you get. Now let's move on to the second one. Let's see, if I compare dy dx, dy over x to equals to du over x. You can't separate this. Let's see. We compare dy over x equals du over u. This one can be integrated, but this cannot be integrated because this is the operator is dy, but it's over x, so it can't be integrated. It is the same thing if you compare the x over y to du over u. This can be integrated, but this cannot be integrated because here the operator is x, and here's the y, the x, and here is y. So it cannot be. So look at the technique that we are going to use here. You know, if we have 3 over 6 like this, the answer will be 1 over 2, right? So this answer here, what it means is that if I add 1 to the 3 and this 2 to the 6, I'll have 4 over 8, which is the same as 1 over 2. I hope you are seeing it. This is algebra. The same thing happens if I have 3 minus 1, 6 minus 2, I have 2 over 4, which is the same as 1 over 2, right? Just understand this. I'm going to use it for something important. Very, very important. So look, what you are going to do here is that if what I said is true, what it means here is that the x over y is equals to dy over x. It's like 3 over 6 is equals to half. Or the x over y is equals to du over u. So you understand this, that this is equals to this is equals to this. So what it means is that if I add these two, then it's equals to du over u. Or if I add this two, then it's equals to dx over y. It's the same thing, just like this thing I prove on the board. So what I'm going to have here is that when I add this, the dx over x plus dy should give us du over u. So this is what I'm talking about. Per the explanation I gave. So in this case, I can integrate this. You see, when it comes to this, you could see that what is here is the same as what is up there. So when you are integrating with respect to your operators, and then I will get ln of x plus y. I hope you understand it. It's like when I have the integral of the x over x alone. This is ln x. But if you look at this one, the y is here, x is here, y is here, x is here. So the operators and the x plus y are the same. So that one will work. And this one to give you ln. So let me make it this way. I'm just looking at where to put my constants. Okay. Plus ln c2. Okay. So that here will give us ln x plus y equals ln c2u. So if you take e on both sides, that gives you x plus y equals c2u. So this is what you are going to get. This is what you are going to get. So in this case, if I want to make c2 the subject, I have c2 equals x plus y over u. Perfecto. So let's look at what we can do. We are now going to equate this. So this one is having u. So when I'm equating them, let me bring it here. Okay, this is the two constant that we have. This one is having u. So for the equation, it will be c2 to equals a function of c1. So my c2 is x plus y all divided by u equals f at y squared minus x squared, like this. Okay, but I want to make u the subject, so I'm going to have u xy. So the general solution is going to be x plus y all divided by f at y squared minus s squared. So this is going to be my general solution. Thank you very much for watching. Now let's look at semi-linear, still under the method of characteristics.